Okay, so this is going to be the video on Unit 12G, which is actually a pretty short handout. There's a bunch of text here at the beginning, and I'll summarize what this text is saying. So the idea is, let's say you had some prism. In this case, I'll make it 1, 2, 3, 4, pentagonal prism. And you wanted to find its lateral area. Then what you could do is figure out what each of these sides are, and then take this side and multiply by the height to get this rectangle, and then take this side and multiply by the height to get this rectangle, and then this side times the height to get this rectangle, and then you do it with the two rectangles in the back too, and then add them all together. But it turns out you could also speed this up a little bit by taking the rectangles that form those 5 walls and unfolding the shape. So you kind of ignore the top and the bottom. And if you do that, then these 5 pieces right here end up forming five pieces that go together at the top, and then these all go straight down like this, and you form some big long rectangle out of the whole thing, right? So if you think of it like A, B, C, D, E, then you could just find the area of this whole rectangle, which is A plus B plus C plus D plus E, times whatever the height is, right? And then you get the whole lateral area all at once. So that's how we came up with the formula for lateral area of a prism or a cylinder is going to be the perimeter of the base times the height of the prism. Okay. So that's one shortcut. Hold on. Okay. So then so far the only way that we do lateral area of a pyramid, like if we take this one on the bottom here, is we would find the area of one of these faces, and assuming that all the faces are the same, which they are for the problems that we've been doing, you would just multiply by however many triangles you have. Well, that works for pyramids, but you can't apply that to a cone because there are no triangular faces on the sides of cones. So we got to come up with a different type of formula that will apply to both, because you can kind of tell that they should be related to each other. So we're going to do it with this specific pyramid down here. Try to come up with a general idea for it, and then apply that to both a cone and other pyramids. So in this problem, let's say that all these bases here, all the base edges are x units long. So all these guys are x going around the base, right? So I'll put an x here, x here, x here. I'm not going to bother with the ones that we can't really see the whole thing. And then it says the slant height is y units long. So the slant height, remember, it's not that, right? That's the edge of one of the, that's a lateral edge. The slant height is the height of one of these slanted faces. So this is the slant height, which is y. So it says, write a formula that represents the lateral area of this pyramid. Well, the lateral area is going to be the area of one triangle times 5. Right? Because there are 5 triangles for this pentagonal base. So we've got 1/2. The base of the triangle is x. The height of the triangle is y. And then we got to multiply by 5. So here's the trick. I am going to not actually multiply any of this stuff together, but I'm going to rearrange some stuff. I'm going to put the half still in front. I'm going to move the 5 so that it's with the x. And then the y I'll keep right there. And if you think about what 5x is, well, there are 5 x's going around the sides here. That's the perimeter of the entire base. So the lateral area is really 1/2 the perimeter of the base times y. Y was the slant height. And it turns out it didn't matter if it was 5 sides to the base, if it was 20 sides to the base. As long as it's a regular base, this formula will always apply. So this applies all regular pyramids and to cones. Because perimeter of the base we can't figure out for a cone. Okay, so let's try a couple quick problems. So this is lateral area for a pyramid or cone. Okay, so in number 1, a pyramid has a regular octagon as its base. Remember, octagon, 8 sides. Each side is 10 inches. So let's see, what else? Slant height of the pyramid is 12 inches. Find the lateral area of the pyramid. Well, now we know if it's got a regular base, which it does, then we've got 1/2 perimeter of the base times the slant height. And this one's not too bad. Well, it's got 8 sides and each side is 10 inches, so 80 for the perimeter of the base. And then the slant height is already given as 12. So it's really just 40 times 12, 480 square inches for lateral area. So there's that one. And let's see, in number 2, we've got a cone. I'll draw this one. Cones are pretty easy. Cone, the height is 8 inches. Remember, that's regular height, not slant height. Base radius is 4 inches. And we need the lateral area. The lateral area for a cone follows the same formula. 1/2 perimeter of the base times the slant height. Well, the base is a circle, so the perimeter of the base is 2 pi r. And then we're going to multiply by the slant height. We know the radius is 4, so that's 1/2 2 pi times 4. And then we still need the slant height, right? So this is the slant height right here. So to get that, let's call that x, and we'll use pi tag. So 4 squared plus 8 squared equals the slant height squared. And then 4 squared plus 8 squared is 80. So that's the slant height if we take the square root. If you wanted to simplify it, let's see. Root 80 is root 4 times 20. Root 20 is root 4 times root 5. So this will turn into 4 root 5 for the slant height. Well, I guess I didn't really need to call it x. I just called it slant height the whole time. So this is 4 root 5. Okay, so then we plug that in right here, 4 root 5. So then the lateral area, let's see, the halves will cancel with the 2, and I'm left with 4 times 4 times root 5, so 16 root 5, and then there's that pi still there. So this would be square inches. If you turned it into a decimal, I don't know, let me check right now. 16 root 5 times pi. Oops, sorry, messed that up. 16 root 5 pi. That'll be 112.397 inches squared. So either this or this would be a good answer there. Let me shrink this down a little bit. The other thing we needed was the volume. Oh no, total area, sorry. So total area, it's going to be all the walls, which is the lateral area, plus anything else that we haven't counted already, which is really just the bottom of the thing. So the area of the one base. The lateral area we already know is 112.397. And the area of the base, well, it's a circle, so it's going to be pi r squared, pi 4 squared. So that's going to be 112.397 plus 16 pi. And if you work that out, oops, I was messing up. 16 pi, we get 162.663, let's say. And then that's total area, so that's also inches squared. Okay, so I hope that helps a little bit, and I'll see you guys soon.